Hello everyone, my name is Deepak Aneja and I am Assistant Professor in the Department of CSTDS in ABES Engineering College, Ghaziabad. Today's my lecture topic is Artificial Neural Networks. So these are the outline of my lecture. First we will cover neural network, then what is artificial neural network, then what is the mathematical model of artificial neural network, then types of activation functions, then characteristics of artificial neural network. So first, what is this neural network? Neural networks are the simplified model of the biological neuron system that is a massively on a very large scale parallel distributed processing system made up of highly interconnected neural computing elements that have the ability to learn and acquire knowledge and make it available for use. Neural network also refers to the learning processing training and the ability to solve the problem using the knowledge acquired as inference according to its observation. Inference means that if we derive from A tends to B, then B tends to C, we can infer knowledge that A tends to C. So this neural networks have the ability to draw these sort of inferences according to his observation. Then artificial neural network. Artificial neural network is the technology which has been built on a simplified imitation of computing by neurons of a brain. Neurons be referred as neurons, processing elements or nodes, or these technology also referred as connectedness network, neurocomputers, parallel distributed system, and artificial neural system. Then mathematical model of artificial neurons. So the basic mathematical neuron model that is given by McClutchford in 1943. This is the neuron having inputs x1, x2, x3, and xn. These are the weights associated to these inputs w1, w2, w3, wn. Weights are the synaptic strength of artificial neurons. These comes to the summation unit. Here we calculate yn, that is net input. Net input. So formula to calculate yn is x1 w1 plus x2 w2 plus x3 w3 up to xn wn. So we can say that this summation of I equals to n xi wi. If there is bias attached to this summation unit, bias has the impact to calculate the net input, and the value of bias is always 1. Then we add, to calculate the net input, we add this bias yn equals to b naught plus summation of I equals to 1 to n xi wi. So here is the bias that we attach, b naught plus summation of I equals to n xi wi. Now this net input goes to the thresholding unit. Here we apply some activation function. This is also called transfer function, Heaviside function, and step function. This is denoted by phi. Y out equals to phi of y in. Here is some value theta, that is called threshold value. Here is some value threshold theta. So this y out equals to phi of y in minus theta. Theta is threshold value. This is our activation function. In case of binary activation function, the value is 0 or 1. If value of yn is less than equals to theta, then final output value is equals to 0. If yn is greater than theta, then y out is always 1 in case of simple linear filter. in case of simple linear filter or binary function. Here is this final y output. So this, in case of binary signum function, the value of theta is some threshold value. Threshold is some spike that is generated over here. So the value of this y out equals to 0 if yn is less than equals to theta, or 1 if yn is greater than theta. If this is bipolar signum function, here we apply bipolar signum transfer function, then the value of y out equals to +1 and -1. +1 is if yn is greater than theta, and if yn is less than equals to theta is -1. Now the types of activation function. Here is binary signum function, as we have discussed. In this case, binary signum function, the value of y out is 0 or 1 if yn is less than equals to theta, or if yn is greater than theta. This is also called binary step transfer function. Here second is bipolar signum function. In this bipolar signum function, there is two poles, -1 and +1. In case of +1, yn is greater than theta, and if value of yn is less than equals to theta, then value of y out is -1. So the value range lies between -1 and +1. It is also known as quantizer function. Then here is binary sigmoidal function. There is one more sigmoidal function. Here there is some slope parameter. The asymptotic values lies in between 0 and 1. Here is some slope parameter that will represented by alpha, and value that is varies between 0 to 1. That may be 0.1, 0.2, 0.3 up to 1.0. So here is some slope that is used. This is binary sigmoidal. So values lies in between 0 and 1. So the formula to calculate final y output, 1/1 plus exponential of minus alpha yn. Alpha is slope parameter. Another activation function is bipolar sigmoidal function. In this bipolar sigmoidal function, there is two poles, +1 and -1. The asymptotic values lies in between +1 and -1. Formula to calculate is final y output is 2/1 plus exponential of minus alpha yn -1. Alpha is our slope parameter. So these are the activation functions that are applied to the threshold unit to calculate the final output. So next is the characteristics of artificial neural network. Basically, the artificial neural network have the ability to derive meaning from the complicated or imprecise data. Imprecise means the data that are not accurate. These have the ability to extract patterns, detect trends that are too complex to be noticed by either humans or other computer techniques. Artificial neural networks have the ability to exhibit mapping capability. So it can map input pattern to the associated pattern. These have the adaptive learning ability. These have the ability to learn how to do tasks based on the data given for training or initial experiences. So these have the ability to generalize the model, so they can predict new outcomes from the past time. Artificial neural networks that must be robust and fault-tolerant capabilities, distributed and parallel representation. These have the ability to distributed and parallel representation. So these are the references for this artificial neural network that I have used. Thank you all.